Hello, this video will discuss the traits that affect the rendering of the progenoforms. Perhaps not in order, but we'll go through them all quite quickly. Maybe the easiest way to visualize what they do is to look at the extremes. So if we look at the first one, which is extroversion, if someone's extrovert, we say they have a big personality. So it's interpreted as being rendered by using big shapes that move around the screen, whereas low extroversion or introversion uses small shapes. If I take the symmetry off, you'll see the little shapes zooming around. And as we move up the scale of extroversion, the shapes get bigger and bigger, which can create different effects. The next one's openness, which is also kind of self-explanatory. If it's low openness, they're all clustered towards the middle. And the higher you go on the openness scale, the more it moves to the extremes of the bounding box, maybe even outside of the box if that's the look that you're going for. Usually about 70–75% is like a composition that takes up most of the image. Conscientiousness is interesting. It's almost a little bit anti-intuitive because the higher the conscientiousness, the less color you'll have left in the final image. It's basically a measure of how the animation cleans up after itself. So if you've got low conscientiousness, then it leaves a colorful trail behind, but that could lead to a too saturated look. And then if you give it more conscientiousness, it'll do a better job of cleaning up, so you have a nice contrast between the active parts and the trail that it's leaving behind. And you will see that different vibes or different color schemes like a different conscientiousness range to a little bit of an extent. So something like autumn leaves, I generally try to have low conscientiousness so that you get more of the autumn colors, not the background color. Whereas one like perhaps fire engine, that will be too washed out. So I'd put the conscientiousness a lot higher so that you get the contrast between like the active flame parts and the trail behind. So that's something to experiment with. Let's go back to that. And agreeableness we'll leave till last because it's the hardest to imagine and to try and visualize. Neuroticism is much easier. It's just really the speed. So low neuroticism is nice and chilled, slow movements, whereas high neuroticism is much faster, crazier movements, and everything in between. And then the last two are to do with duration. So vitality is how long the shapes move around the screen before they come to this final part where they sort of move to a single point and create these leaf-like structures. So higher vitality means that they'll just keep going round and round longer before they start ending the animation. And then when they do end, the perseverance defines whether they come to an abrupt end straight away or whether it will continue going and slowly peter down to a single point, so you get much longer trails when you've got high perseverance. And then coming back to agreeableness, which is interpreted as being its ability to orient to different points of view. So agreeableness causes a like multi-dimensional rotation. It's not that easy to predict because it's not just a simple 3D rotation. It's a rotation of various axes within the algorithm. So you'll find that if you just tick it up one by one, there is a relationship between each one that you come to, but even after about 3 or 4 or 5 upticks, you'll be at a totally different look than what you started. So I like to try and get everything else the way I want and then just tick up agreeableness one by one, keeping track of my best version so far, and just keep going until one pops out that I really like. And the last thing is the symmetry. So 60% of the tokens at Mint have no symmetry. They're just these shapes moving around the screen. But if you do have an interesting thing happening on the left side, you can try partial symmetry, which will just mirror the left to the right. So it's like a vertical mirror that gives you that symmetrical look between left and right. And then you could go full symmetry, which is everything in the top left corner gets projected across and down, so you get basically four of the same, which gives a kaleidoscope type of effect. And again, this is just renderer 0, the first renderer, but I think all the renderers that are brought out will have similar interpretations of the traits, or definitely some interpretation of the traits, to make it possible to create the progenoform that you like. And then there is an interesting thing to consider, because we do have difficulty visualizing anything more than 3D. But this is kind of a mapping from this. It's actually a 10-dimensional space into a 2-dimensional space plus time, I guess, is a 3-dimensional render. And if you just look at the static image of each token, which just gives you these 7 traits in order, after a while you can sort of predict what it's going to look like if you know the order. Like this one is the speed, so you can tell if it's going to be fast or slow. The first one is the size, so you can know if the shapes are big or small, and you can look at the last 2 to see the duration. So you can definitely get a mapping between each progenoform, which is represented by 10 values, so it can be thought of as a 10-dimensional vector space, back to something that we're more used to visualize, like a 2D animation over time. Thank you.